when you learn it by referring to this, what you had learned earlier, what was clear to you before, it becomes very simple. This is my approach. Hi students, today's topic is projectile motion. Say, we have a ball in our hand, a cricket ball. When we throw it, we see that it goes along a path like this. So if we throw a ball from the ground, it traverses a path like this. So this motion is called projectile motion. What happens in a motion like this is that when we throw the ball, we give it an initial velocity, let's call it u. Say we are throwing it at an angle of theta with the ground. Okay, then when it moves along this path, there is only one force acting on it, which is the force of gravity. So due to Earth's gravitational pull, it follows a path like this. So this type of motion is called a projectile motion. So you are throwing something, means you are projecting something. So what you throw is a projectile, and the motion is called projectile motion. Okay. So here right now we know only three things. One is the initial velocity was u along this direction, making an angle theta with the horizontal, and there is only one force acting on it, which is the force of gravitation. By knowing only these three things, we want to find how far it will go, how high it will go, and how much time it will take in its flight. We want to know this type of things from here. Okay. Now, the way I am going to teach you this topic will be different from what is followed in the NCERT book. I think you will find my approach simpler to understand, simpler to remember. Okay, so concentrate. Okay. See, if we consider a point here P, so the projectile has reached this point P after time t seconds. This is we are assuming, say after t seconds, the projectile reaches this point P. Okay, so at this point it will have a velocity, so we can draw a tangent to this curve. So if I call that velocity v, it will have a velocity v along this direction. Now, as you can see easily, this is a two-dimensional motion because the coordinate of x is changing of this point, and the coordinate of this point y is also changing. Okay, so what usually we do in case of a two-dimensional motion? What we can do is we can resolve this velocity into x component and y component. Let's call it vx, let's call it vy. Now see, initially the velocity was u. If I make components here, this will be u cos theta, this will be u sin theta. This is a vector u, so I am resolving it along x direction. So this is u, this is theta, so u cos theta, and in the vertical direction it will be u sin theta. Clear? Okay. Now at this point the velocity is v, so we can write v is equal to vx I cap plus vy j cap, right? Because v we have divided into vx and vy. This is along x direction, so vx I cap. This is along y direction, so vy j cap. Clear? So let's find out how much is Vx, how much is Vy. Let's find expressions for them. Now look at this part. When the object is here or here or here, what is the force on the object? Only the force of gravitation, which is vertically downward. Is there any force on the projectile, that is on the object, in the horizontal direction? No. Since there is no force on the projectile in the horizontal direction, its acceleration along the horizontal direction will be 0. Right? If the acceleration is 0, that means the velocity will remain constant. So initially the velocity was u cos theta. So it will remain, the horizontal velocity will remain as u cos theta at every point. That means this Vx will be u cos theta. Understood? Simple, right? Okay. Since there is no force on the projectile in the horizontal direction, so it doesn't have any acceleration in the horizontal direction. That means its velocity will remain constant. Initially, its horizontal velocity was u cos theta. So at any point, its horizontal velocity will be u cos theta. Clear? Okay. What about the vertical velocity? In vertical direction, there is a force on it. Vertically downward, the force of gravity, due to which it will have an acceleration, g, acceleration due to gravity, right? So when we are thinking about the vertical component of the velocity, we can compare it with a situation like this, which you had learned earlier in one-dimensional motion. So if I have a body, if I throw it with a vertical velocity u, it goes up, right? At any point, its velocity, if I call it v, this is given by u minus gt, right? Initial velocity u, retardation, so minus g into t. So compare this with this. Here the initial velocity or the initial velocity in the vertical direction was u. Here the initial velocity in the vertical direction is u sine theta, right? Because u was in this direction it is u sine theta, right? Here there was retardation, here also there will be retardation because the force is downward. So after time t, the velocity was u minus gt. This you had understood very well in the motion in one dimension chapter, right? So let's apply this knowledge here. So velocity in the y direction is equal to initial velocity, which is u sine theta, minus gt, right? When you learn it by referring to this, what you had learned earlier, what was clear to you before, it becomes very simple. This is my approach. Okay, instead of teaching this in a different way, okay, I'm going to teach you from what you know already. Okay, you will find it much easier to understand, much easier to remember in the future also. Clear? So at this point, the velocity was v. We have made two components here. Vx we have found out to be this. Vy we found out to be this. So v will be this Vx. Now I had written it in vector form, so I should write it in vector form here also. So Vx is u cos theta. So u cos theta I cap. I am putting a bracket to make it clearer, plus Vy is this much, so u sine theta minus gt j cap. right? So this is in vector form. So this is in vector form. So velocity v at this point P is given by this equation. So if in the exam they ask you to find the velocity at a point P after a time t seconds when a projectile is thrown with a velocity u and angle theta, you can write this expression, you should get full marks. Okay, because from this vector we can find the magnitude, we can find the direction, right? But usually in the exam what they expect is, they expect you to find the expression for the magnitude of the velocity. So for that you proceed like this. It's very simple. You know this is a vector, so you know how to find the magnitude. I think you remember that. Okay, let me do it here. If you have a vector A which is given by ax I cap plus ay j cap, this was a vector A. What is its magnitude? Square root of ax square plus ay square. From vector you remember this, right? So here also this velocity is given in a vector form. So if you have to find the magnitude of this, so magnitude of this will be square root of this square plus this square. This square means u square cos square theta plus this square means u square sin square theta plus g square t square a square plus b square. So this will be minus twice u g t sin theta. This is under this square root. So here if you take u square common, you will get cos square theta plus sin square theta, which will become 1. So what we will get? We will get u square here plus g square t square minus twice u g t sin of theta. This is the magnitude of the velocity. Clear? See, it is so simple to find this. It will be so simple to remember how to find this. I repeat, it will be so simple to remember how to find it. Why? Because we know if we have a vector like this in the I cap j cap form, we can find the magnitude simply using this square root of ax square plus ay square. Here we have found the velocity in terms of I cap j cap similar to this. So we use this formula to find the magnitude. Clear? If we have to find the direction of this velocity, that is this angle, the angle it is making with the horizontal, if we call it beta, then how do you find the angle here? Here tan of that beta would be coefficient of j cap divided by coefficient of I cap. Here we can use the same technique. How? Like this. Tan of beta will be coefficient of j cap, that is u sin theta minus gt divided by coefficient of I cap, that is u cos theta. So this will reduce to this by this, u will cancel out, sin theta by cos theta is tan theta, minus this will remain as it is gt minus u cos theta, this is tan beta. Clear? So once you put this velocity in the vector form, you can easily use your knowledge of vector to find its magnitude, to find its direction. Clear? So this is one part of our study, what we want to find here. Okay. Okay. Now we want to find the time of flight. How long it will take to go from here to here. Okay. So time of flight, let's call it capital T. Okay. Now see, this situation is similar to this. If you throw an object with an initial velocity u vertically upward, it goes to a maximum height, then it comes back, falls back to the earth. The velocity at the top point is how much? 0. Correct. When you throw it vertically upward, its velocity at the top point is 0, then it again starts falling downward. Okay. Now compare this with this. See, the horizontal component of the velocity is taking it towards right. It is not affecting its vertical direction. The vertical velocity is what is controlling how high it will go, how much time it will take to reach the highest point. Okay, so what we had called u here this is u sine theta. Okay, so initial velocity here was u, here the initial vertical velocity is u sine theta. At the top point, the velocity was 0. From there, we had used this equation. I think you remember the equation was v equal to u plus at. From this equation, at the top point, v was 0, u was u, a was minus g, and if we say t1 was the time taken to reach the top point, this was t1. From there, we had got t1 is equal to u by g. This was the time taken to reach the highest point. Similarly, here also we can see that the initial velocity is u sine theta. At the top point, vertical velocity will be 0. So that means at the top point, vertical velocity will be 0. I'm writing from here. Initial velocity is, here it was u, here it is u sine theta, minus it was gt1, so here also say gt1. Say we are saying to reach the top point, time needed is t1. This equation is similar to this equation. At the top point, the vertical velocity is 0. Initial velocity, here we had called it u, here it is u sine theta. Then acceleration is the same here, minus g, time taken is t1. Right? So from here, we get t1 is equal to u sine theta divided by g. This is the time taken to reach the highest point. Here the highest point is at this point, here the highest point is here. Okay. Now we want the time of flight. Time of flight means the total time. We know that the time of ascent is equal to time of descent. So if it takes 2 seconds to go up, it will again take 2 seconds to come down. So total will be 4 seconds. So if it takes t1 seconds to go up, total time of flight will be twice t1. Similarly, here also the total time of flight will be twice t1, that is 2u sine theta divided by g. Okay, so this is the equation for time of flight. You can now omit this. Time of flight is equal to 2u sine theta by g. See, this was clear to you. From there, we have derived this. Very easy to understand. Clear? Okay. Now let's talk about this distance. This is called the range. usually it is written with r. How far it will go. Okay. Now you see, in this direction, the velocity is constant. This we have understood before. The horizontal velocity remains constant, which is u cos theta. So with this velocity, it moves to the right for a time of this much. So how much will be r? R will be this velocity in the x direction, multiplied by for how long it is moving? For time t, that is the time of flight. So if you multiply by putting the values, Vx is u cos theta, this is u cos theta, time of flight is 2u sin theta by g. Okay, so what do you get? We get u, 2 u here, so u square, 2 sin theta cos theta, we combine it to make it sine of 2 theta divided by g. So the formula for the range is this. Okay, it's very easy to find. This range, this distance is equal to this velocity multiplied by the time of flight. So we get this. You have to memorize this equation. Okay, then you should also know how to derive it. Clear? For entrance point of view, you have to memorize them. For class 11 final, you should know how to derive them also. Okay. Now let's say, what is this distance h? How high it can go? We call it maximum height. Now we want to find this h, the maximum height. Okay. Now we can use this equation, v square equal to u square plus twice gs. So at the highest point, this velocity in the vertical direction will become 0. U, initial vertical velocity was u sin theta, minus twice g, and s will be h. Okay, this is similar to this case. Say we had thrown a ball vertically upward. This h we can find at this point, final velocity is 0. So use this equation, 0 equal to u square minus 2gh. In this case, instead of u, we just have to write u sin theta, the vertical component of the initial velocity. Rest is same. So from here, we'll get h is equal to u square sin square theta divided by 2g. This is the equation for maximum height. Okay, have you noticed something here? If you have learned this in your class, in your school or college, the derivations were much longer than this. And to remember the derivations, to understand the derivations was also difficult. Here, it is simpler. In this approach, it is simpler. Okay, this is the way actually to learn physics. When you learn a new concept, you should make use of your knowledge of simpler concepts. And from here, you should learn what is to be modified, what other thing has come, what new concept has come here. Just add that modification, you will get the formulas for the new situation. Okay. In the NCERT book also, they are not using that I cap, J cap approach. Okay, in the some of the other books also, they are using the normal approach, that is without I cap J cap approach. But if you use the I cap J cap approach, if you compare these situations with situations like this, it becomes much easier to understand the whole concept. So when it becomes easier to understand, you will also remember it for longer time, and in the exam also you will tend to make less mistakes, or in fact you won't make mistakes. Okay, now you should remember this formula also for entrance purpose. Okay, now see what we have found out. We have found out the range, formula for range, formula for maximum height, formula for time of flight, formula for velocity at any point, the magnitude of this, and the angle beta this velocity makes with the horizontal. So these are all different things we have found out at till this stage. Okay, now there is only one more thing to learn here, to derive here, which is we have to show that this path will be a parabolic path. That is, like we have a straight line in geometry, we have a circle in geometry, we have a parabola in geometry, we have a hyperbola in geometry. So this path is a parabolic path that we have to prove. So now we have to prove that this path followed by a projectile is parabolic. So it is a parabolic path, we have to prove that. For this, we can proceed like this. The projectile is at point P after a time t. Say the x coordinate of this point is x and the y coordinate is y. Okay, so this x will be how far it will go from here to here in time t? The horizontal velocity multiplied by time t. So at this point, x will be t into u cos theta. Okay, and how much will be y? In this direction, there is acceleration, in fact retardation. Okay, so this will be, y will be equal to, we use this equation, s is equal to ut plus half g t square, because there is acceleration in the vertical direction. To find the distance, we have to use this equation, right? So this y is the distance, so we'll be using this equation. So ut means initial velocity in the vertical direction, which is u sin theta multiplied by t. This will become half, g will be minus, so minus g t square. So the equation for y will be this and equation for x will be this, right? So if I call it equation 1, equation 2, first concentrate how we got these equations. Let me repeat. In the x direction, the velocity was constant. So simply velocity into time. So time is t seconds to reach this point. So t time into velocity is u cos theta. That is x. Simple. In the y direction, there is acceleration due to gravity. It is decreasing the velocity. So this is minus. Since there is acceleration, we'll have to use this equation. So instead of s, we want to find this distance. So this distance is y. So y equal to t into initial velocity is u sin theta minus half g t square. Simple. Right. Now, the next point you have to understand is that find an equation of path means you have to find an equation between x and y. Okay, When we want to find an equation for the path of an object, we have to find the equation between x and y. So now look at these two equations. What all we have? We have x, we have y, and also we have t. These are the variables we have. U is constant because we know we have thrown it with a velocity u. Theta is constant in the sense we know this is the initial value, we threw it with an angle theta. Okay, but the variables are, that is which quantities vary? X varies, y varies, time varies. So after getting these two equations, what you have to remember, what you have to understand and memorize is that the only thing needed now is to remove this variable t from these two equations. If we remove this variable t from these two equations to get one equation, in that equation only x and y will be there, and that will be the equation of path of this projectile. As simple as that. Okay, now this is mathematics of class 8-9. You have two equations. You want to remove t from here. What would be the easiest way? From equation 1, you say t is equal to x by u cos theta. X by u cos theta. Then you replace this value of t in the second equation. So y becomes, instead of t, I will write x by u cos theta into u sin theta minus half g t square, this square, so means x square divided by u square cos square theta. Okay, now see in this equation there is no t. What we have? We have only x and y. The variables we have only x and y. So we can simplify it. This u will cancel out. Sin theta by cos theta will become tan theta. So this will be tan theta into x minus g 2 u square cos square theta into x square. Intentionally I am writing it like this. I have written the x here, I have written x square here. Okay. Now this equation is an equation of a parabola. So equation of a standard equation of a parabola is ax plus bx square. Like the equation of a straight line is y equal to mx plus c. Similarly, there is a standard equation for parabola, which is this. If you haven't learned it yet, you will learn it in mathematics. Okay. Now if you compare this with that, a is tan theta here, b is this quantity here. In this standard equation, a is a constant, b is a constant. In this equation, theta is a constant because we have thrown it at a particular angle theta. So tan theta is a constant, so tan theta is a. In this equation, g is a constant, u is a constant because we have thrown it with a particular velocity. Theta is a constant, so this part is constant, this is b. Minus of the whole thing is a b. So this equation is in the form of this, which is the equation of a parabola. That proves that this equation representing the motion of a projectile is a parabola. That means the projectile follows a parabolic path. In the exam, what you can do is, you can derive after this, then you write that The standard equation of a parabola is this. Comparing this with that, we see that this represents a parabola. So the path of a projectile is a parabola, or the projectile follows a parabolic path. That's all. Clear? So let me tell you something more. See, I have seen many students, in fact 80% of the students memorize the whole thing. Okay, they try to memorize the whole thing, so somewhere if they make mistakes, everything goes wrong. Actually, you don't have to memorize the whole thing. See, what we have to understand is that at a particular point, if we take the coordinate to be x and y, x will be simply time into horizontal velocity. This you can remember, this you understand, you can memorize, you can write in the exam. Okay? In the vertical direction, there is acceleration, so we have to use this equation. So y will become this much. This you should understand. It is not difficult. You should be able to write it in the exam. Okay, so after obtaining these two equations, what you should understand and memorize is that now I have to remove t from here to get an equation between x and y. So from here, t will be this much. Replace t here, then you get this. Then you memorize this equation. Compare this with that. This is a parabola. Don't have to memorize step by step. Memorize the main steps, main concepts. That we'll take an arbitrary point after time t. We'll say its coordinate is x and y. For x, we'll get this equation. For y, we'll get this equation. Then I will remove t. Done. Clear? So note all this down. Then, if needed be, watch the video again. Now at the end, I would like to tell you that my approach was different than the approach given in the NCERT book, or most probably the way it was taught in your school or college. Okay? Or maybe what you have got in other books. Now give me the feedback by writing comments below the video. Okay? Whether this approach is better and other approaches were better. I personally find this approach better. I think you will also find this approach better. Okay? Just give me the feedback. I would appreciate that. Bye.